Welcome. In this video, we would like to show you how to calculate a project in emaPlant Designer and how detailed the results are. You will also find additional videos on the following topics. What results can you expect from emaPlant Designer? What data is relevant for the digital model of the factory? How is the digital model created? How can data be customized in the user interface? How can a lean layout be designed? And how can transport equipment be planned? We will show you the results directly in emaPlant Designer using the example of gearbox assembly. First, we open the project and start the calculation. To do this, simply click on the Start Calculation button. Depending on the scope and complexity of the project and the calculation settings selected, a calculation takes only a few seconds to minutes. A window then appears with the calculated results, showing an overview of the most important key figures, including the unique ID of the result, the corresponding calculated production area, production quantity, costs, and number of employees. Since different variants of employee assignment were created with only one calculation in this example, 4 results are listed. We select the result with the lowest number of employees to look at the results in detail. For each calculated result, there are a number of result tabs containing various detailed data. Here we present just a few selected tabs. The first result tab is the Quantities tab. This shows whether the planned quantities of the entered products can be achieved with the work plans and resource data used. As in most other result tabs, the result is displayed both graphically as a diagram and in tabular form with detailed values. In this example, the planned quantity is not achieved, so the bars in the diagram, each representing a product family, are colored red. The next Results tab, Workplaces, shows an overview of all workplaces used and their utilization rates. For each workstation, there is a diagram showing its working time, setup time, planned and unplanned downtime, planned occupancy times, and the resulting free capacity. The table shows the number of workplaces entered and dimensioned, the ratio of setup time, and the utilization of the workplaces. Clicking on the column header allows you to sort the data in each column. This enables you to quickly identify the workplaces with the highest utilization, which are also the bottleneck and cause for the unachieved planned quantities here. The workplaces with the highest ratio of setup time and with the highest utilization rates are also colored red, while those with the lowest utilization rates are colored orange. Next to this, the calculated OEE, consisting of availability, performance, and quality factors, is displayed. Here, the workplaces with the lowest OEE are colored red. In addition, further detailed values are provided for each workplace, including the number of hours of unplanned downtime per year and the process time per year. The sum of these values represents the annual runtime of the workplace. Together with the setup time, this results in the annual action period. This is contrasted with the annual working time of the workplace, which, minus planned downtime or occupancy times, gives the capacity. The difference between capacity and action period ultimately gives the free capacity, which is equal to 0 in the case of bottlenecks. Let's take a look at the Production Areas Results tab, where you can see the required space at workplaces and in warehouses, again displayed graphically on the left and in tabular form on the right. The warehouses, incoming goods storage, interim storage, and outgoing goods storage, are displayed on the left-hand side. If the transport aids have been assigned to storage groups in the library, the storage groups are displayed within the warehouses. Otherwise, the different types of transport aids are displayed. Each box within the warehouses represents a transport aid or a stack of transport aids if a pile factor has been specified. Dark blue boxes represent storage locations that are required on average over the planning period. Light blue boxes represent storage locations that are required in addition at maximum. And purple boxes indicate the required safety stock in the incoming goods warehouse. The storage locations required for material provision are displayed in front of the workplaces, whose base area is shown in white and whose workplace area is shown in gray. Here, the yellow boxes represent the empty containers in which finished parts are placed, the orange-brown boxes represent items that are placed at the workplace from the incoming goods storage or interim storage, and the green boxes represent items that are placed directly from the previous workplace using push control. This can lead to long queues of orders, especially at highly utilized workplaces, with the number of waiting production orders having different probabilities. Orders that are highly likely to be waiting for processing at the workplace are colored darker than orders that are only rarely found at the workplace. The tooltip provides more detailed information about the types of transport aids and their probabilities. Switching from push control to pull control would also mean that Kanban containers would be calculated and displayed here in the Production Area tab. More detailed values regarding the number and area of the calculated storage locations can be found in the table on the right. The next Results tab, Material Flow, shows how many transports take place between the individual warehouses or workplaces each year and how high the annual transport efforts are, taking distances into account. Here in the gearbox assembly project, for example, 582 transports are carried out annually between the bandsaw machine and the CNC center lathe, which means a distance of 33,211 meters. Transport relationships with particularly high efforts are shown in red. These workplaces or warehouses should be arranged as close to each other as possible in the layout in order to reduce transport efforts. The next Results tab, Lead Times, shows the lead times for the products, again in graphical and tabular form. The left-hand section shows the total time for the production of a batch for each product. This is calculated by summarizing the process, setup, waiting, production or lay times, transport, and external processing times, as well as the time spent in storage for all items that go into the product. The lead time for the product is also displayed. Only the times for the operations on the critical path are included. The table shows all in-house manufactured parts that go into a product and their operations, such as the operation, pre-assembly drive shaft, for manufacturing the drive shaft complete. In addition to process times and production batch sizes as input variables, the system displays the time of material in the incoming goods warehouse, process-related waiting times, setup times, process times, lay times, transport times, residence times in the intermediate warehouse, and external processing times in hours per production batch for each individual operation. The sum of these values is the total time. In addition, the ratio of processing time to total time and further information on the critical path can be found. The Employees tab provides information about which employees with which qualifications should operate which workplaces in which shifts in order to achieve the best possible assignment of employees to workplaces. This also takes into account multi-machine operation, that means the operation of several workplaces by one employee or a group of employees. The diagram on the left shows how many hours per year an employee or group of employees with a specific qualification and shift operates and sets up workplaces, and how much free capacity remains. The table on the right shows the detailed ratio of setup time and utilization rates, as well as the setup and operating times in hours per year. In the results displayed here, for example, 3 employees with the qualification of fitter are required per shift to jointly operate and set up the 5 workstations pre-assembly drive shaft, gang drilling machine, marking place, manual workplace and pre-assembly output shaft. This group of employees therefore has a ratio of setup times of 7.68% and a utilization of 81.08%. All results calculated so far in this project are stored in the database and can be reopened later. In addition, each result can be exported to an Excel file. This file contains all result tabs from the emaPlant Designer user interface as worksheets with all relevant results. Alternatively, the result can be used to create a layout in the 3D interface of emaWork Designer. To learn how to transfer the calculated result to a layout and how to make it lean, watch the video entitled, "How can a lean layout be designed?" Thank you for your attention.